In this tutorial, we will discuss the types of signals and mathematical descriptions associated with each type of signal. If you have any question related to anything explained or presented in this video series, don't hesitate to contact us via email or comments at this channel. So we start. First, we recap the mathematical representation of a signal as explained in last lecture. Signals can be represented as a function of one or more than one independent variable. As an example, we show the two signals below in which t is an independent variable and f of t is a dependent variable as its output depend on variable t. Well, t is an independent variable. Generally speaking, it can take value from -infinity to +infinity. In all these video series tutorials, we will only be dealing with single independent variable. We will generally refer this independent variable as time t. Signals can be classified into two types: continuous time signal and discrete. Time signal. So what is a continuous time signal? A signal with continuous independent variable or a signal defined for a continuum of values of independent variable. Let's look at few examples. A speech signal as a function of time as shown here. Now we move to discrete time signals. Well, discrete time signals are defined only at discrete times, and consequently, for these signals, the independent variable takes on only a discrete set of values. As an example, a weekly stock exchange prices chart can be referred as discrete time signal. Now, as we have established the basic concept of continuous and discrete time signals, so we move to notation that will help us to denote these signals. So based on most of literature, we have seen the discrete time and continuous time are represented in different ways in most of the books. But we adopt the most frequently used way, which is shown below. For continuous time signal, we will use symbol t for independent variable enclosed in round brackets, parentheses. For discrete time signal, we will use n symbol for independent variable enclosed in square brackets. Remember that the variable t in continuous time signal can take on any value from -infinity to +infinity, while the variable n in discrete time signal can only take integer value. As an example, we show the graphical representations of the two types, along with notations that we introduced just now. This is all about types of signals. In next few videos, we will visualize different kind of signals along with few other mathematical operations for signal analysis. Our goal is to help you out to understand the basic concepts in a very simple and clear way. Thanks for watching and subscribing us. See you in our next video. Bye.